Okay, Kirsten, when we're doing this, right, one of the things you want to do when you have a fraction like this, look at the same basis like this, right? So when I combine these two, what do I get? A to the?
1.
Well, it's 3 minus minus 2, which makes it?
Oh, 5.
5, right. So this is, and then you put in the denominator, b to the second, right?
Yeah.
And this one becomes just 25 and 16 like this. Now, the second thing that you want to look at is that negative exponent. When you see that, you should remember that when you have a over b to the negative k, that's b over a to the positive k. When you change the sign of the exponent, you flip the base like this. So I'm going to do that right now. So that's 16 b squared, 25 a to the 5th. Now let's get the denominator. Isn't that the square root right there? So let's apply that first. What's the square root of 16?
4.
What's the square root of 5? 25?
Yeah.
The square root of that is?
B.
B. This one doesn't divide evenly, so I'm going to leave it as a fraction. Okay, so that's a to the 5 halves. And you're left with the 3 over here, right? So now you apply that, which 4 to the 6th is? Sorry, 4 to the 3rd is? 16 times 4 is 64, right? And 5 cubed is?
125.
That's right. And b cubed is?
B.
And you multiply these two values to get a to the 15 over 2. Now, depending on the direction, I probably usually say that you should leave it as a positive exponent, then this is fine. And you always check, do numbers cancel? It doesn't, right? Then you leave it alone. Okay?
So you can have the fraction exponent.
That's fine. I'm okay with that. I'm okay with that. I think the direction said the rationalize all irrational denominators. I'm going to get rid of that. Okay? That's something that we didn't practice a lot, so I'm not going to expect you to do that. We'll cover it sometime in the future, but this is good.
Okay.
Okay, anything else on this question? All right.